Alright, we're back with another video for Chapter 5. This is Section 5.4, which is all about monthly payments. There's a fancy name for monthly payments. They're called amortized loans. And I just wanted to mention before we get started that the formula that you're going to see in this section is really complicated. But really, the one that people have the most trouble with seems to be in 5.2. People seem to catch on to this one pretty quickly. It just takes a little bit of practice. Alright, so some loan terms that you should know before we get started. An amortized loan is a loan for which the loan amount plus interest is paid off with a series of regular equal payments. This is going to be like your car loans, your mortgages for houses, like anytime you take out a loan to buy something big like a boat or a building or anything like that. A simple interest loan, we've already talked about this. A simple interest loan is a loan whose interest is simple interest and it's computed on the principal that is owed. So again, you're not paying interest, only interest. The current balance is the part of the principal that you still owe. And a simple interest amortized loan is a loan that is a simple interest loan and also an amortized loan. So it's a simple interest loan that you pay back monthly. Now, I should point out, I said that you pay it back monthly. There are some loans that maybe you don't pay back monthly. Maybe it's every other month, maybe it's every 6 months, but most of the time, amortized loans are paid back monthly. All right, so I need to go through this really quickly. I know it's really long. It says, simple interest amortized loans are the type of loans that you have for your house or your car. With this type of loan, the interest is paid only on the outstanding balance. Alright, so you're only paying interest on how much you owe, which means that if you make an extra payment, that's going to cut down on the amount of interest that you have to pay. So maybe 1 month you make 2 payments, it's going to cut down on the interest that you pay. As the borrower makes payments on the loan, the outstanding principal on the loan decreases, and accordingly, the amount of interest that you're paying likewise decreases. But the amount of each payment remains the same. So as time goes on, as you get closer and closer to the end of your loan period, more and more of each payment is used to pay down the principal and less of it is being used to pay off interest. So what that means is that if you go and you buy a car, at the beginning of your loan period, you're just making payments towards the interest that you owe. And towards the end of your loan period, that's when you really start knocking down that principal. Alright, so that's why it may look like at the beginning of your loan period, it may look like you're thinking, where are my payments going? How do I still owe this much money on the car? As your loan period goes on, that principal starts to go down quicker and quicker. Here is your formula. I know it looks really intimidating, but I promise you'll get the hang of it, and it's really, like I said, this one is not the one that people seem to have problems with on the test. The hardest one on the test seems to be the 5.2. So simple interest amortized loans. This is how you calculate the payment. So here's what you need to know. You got to know the principal, so that's how much you're paying for, let's say, the car or the house. You got to know the interest rate, and you got to know the time or the term of the loan. So how long are you financing this thing for? Alright, so here's the formula. Payment equals, on the top you have P times R over 12. So that's principal times the interest rate divided by 12. Of course, that interest rate needs to be in decimal form. So all of that divided by 1 minus, parentheses, 1 plus R over 12 raised to the negative 12t. Yes, that is always negative down there. So always negative 12t in the exponent. Alright, so let's look at an example. Alright, so we're back with Tom and Betty. If y'all remember, I think the last 2 sections we had an example with Tom and Betty. Alright, so it says Tom and Betty decide that they need a more dependable car now that they have a baby. They buy one for $13,518.77. They make a $1,000 down payment and they finance the rest through a 4-year simple interest amortized loan from their bank. And they are charged 12% interest. This is a terrible interest rate. All right, so let's look at what we got going on. They want us to find their monthly payment, and then they want us to find the total interest that they will pay over the life of the loan. All right, so finding their monthly payment. Here's the formula for the monthly payment. All of these examples that we're going to look at all are monthly payments or monthly loans. All right, so we need to know the principal, we need to know the interest rate, and we need to know the time or the term of the loan. It's always in years. All right, so it says this is a tricky one. They won't be this tricky on the homework or the test, but this is kind of a tricky one. They buy the car for $13,518.77, but they make $1,000 down payment. So we're going to take $1,000 right off the top. All right, so we're taking our sticker price minus $1,000. So this is how much they're actually financing. That's the principal. So the principal is how much you finance. All right, so they financed this car for $12,518.77. That's P. All right, now the interest rate. Well, excuse me, I'm just going through the sentence here, and I noticed that there's a 4-year, it's a 4-year simple interest loan, so T is 4. Now we'll take care of the interest rate. Since it's 12% interest, convert that to a decimal, so R is 0.12. Now we just need to plug those numbers in. All right, so there we go. Payment equals, all right, parentheses around the top. I have a bracket here. You don't have to put a bracket in your calculator. These are the same thing as parentheses. All right, so when you see these, this just means put a parenthesis in your calculator. I just used the brackets because I already had one set of parentheses in the bottom. So I didn't want it to look too heavy with parentheses. All right, so again, all these are just parentheses. All right, so 12,518.77 times 0.12 divided by 12. All right, so 0.12 comes from the interest rate. And in the denominator we have parentheses, 1 minus, then another set of parentheses, 1 plus 0.12 divided by 12 raised to negative 12 times 4. Now what you're going to do next, every single time what you're going to do next is you are going to multiply out the exponent first. Do that first. All right, so always do that first. So if you multiply out negative 12 times 4, that gives you negative 48. Let me just get rid of these lines here. All right. Now that you have gotten rid of that product up there, you've got that simplified. Now we can go ahead and plug this in the calculator. So here I am showing you how to plug this in the calculator. I'm going to let it run through one time and then I will explain what I'm doing. Okay, so we have parentheses around the numerator. So we have the 12,518.77 times 0.12 over 12, close the parentheses, divided by, open up another set of parentheses, 1 minus, and then we got the extra set of parentheses inside. So parentheses 1 plus 0.12 over 12, close parentheses, raised to the negative 48. Don't use a minus there or else it'll give you an error. All right, and then close those parentheses. All right, so there's Tom and Betty's monthly car payment. All right, so take a second, make sure you can get this same answer in your calculator. There's their monthly car payment, $329.67. All right, now comes the sad part, where you find the total interest that you're paying over the life of the loan. All right, so really simple to figure out the total interest. I'm sure you could probably, there's no formula for it. I'm not going to give you a formula for it. It's just, I'm going to let you figure it out intuitively. So Tom and Betty make monthly payments of $329.67 for 4 years. All right, so 12 times a year for 4 years. So that's $329.67 times the 12 months a year times 4 years. So this is how much they actually pay for the car. They actually pay $15,824.16. Now, of course, this is assuming that they never make any extra car payments during the month. All right, so if they make any extra payments, this will be different. Now, they only financed $12,518.77. We can find the total interest that they'll pay over the life of the loan just by subtracting the amount they financed from the total amount that they paid. All right, so total interest equals $15,824.16 minus the amount that they financed, which was $12,518.77. So over the course of those 4 years, they pay $3,305.46 in interest. So again, this was a pretty high interest rate. 12% interest is pretty high, so that's why they're paying so much interest over the 4 years. All right, let's look at an example from the homework. This will be exactly what your question on your test looks like. It won't be a word problem. I'll just give you the principal, I'll give you the interest rate, and I'll give you the term of the loan. And I'll ask you to tell me the monthly payment. I won't even ask you to do part B on the test. It says the following loan is a simple interest amortized loan with monthly payments. And it says round your answer to the nearest cent, which we know is 2 decimal places. All right, so it's a $150,000 loan. So this might be like a house loan. 9.5% interest for 35 years. Find the monthly payment. All right, so there's our formula for payment. All right, so we need to know the principal, we need to know the interest rate, and we need to know the term or the time of the loan. Principal is $150,000. Interest rate, we need to do a little bit of work on that. So 9.5%, that's 9.5%, that's 0.095 in decimal form. All right, then T is going to be 35. All right, so I'm plugging in my numbers. All right, plugging in my numbers, I get 150,000 times 0.095 over 12 divided by 1 minus, in parentheses, 1 plus 0.095 over 12 raised to negative 12 times 35. All right, so I'm going to show you, first of all, don't forget, what do we got to do to that exponent? You got to simplify that exponent first. All right, very, very important. All right, so I've simplified the exponent. Negative 12 times 35 is negative 420. All right, so now I'm going to show you how to plug it in your calculator. Again, I'm going to let it run through one time, then I'll let it start over, and I'll tell you what I'm typing in. All right, so parentheses around the top, 150,000 times 0.095 over 12, close those parentheses around the top, divided by, parentheses around the bottom, 1 minus, parentheses again, 1 plus 0.095 over 12, raised to the negative 420 power, then close those last set of parentheses. All right, so there is our monthly house payment. All right, so $1,232.42. All right. So what do you guys think? Does that seem like a reasonable house payment for a $150,000 house? Seems a little expensive to me, but that's just because the interest rate is so high. Now, one way that you can sort of check your answer with these is you got to think, is this a reasonable answer that I'm getting? if you get back an answer like on this one, I've seen people write down like a payment of $1 million, like over $1 million. You know that's not right if you think about it, because the loan is only for $150,000. Your monthly payment isn't going to be over $1 million. All right, so you want to kind of keep that in mind as you are going through these problems. Think about, does this payment seem reasonable for the amount that I'm financing? All right. Now I need to find the total interest. We're going to do this the exact same way that we did the last one. All right, so let's think about what we're doing here. We're making a payment every month of $1,232.42. We're making that every month for 35 years. All right, so the total amount that we're paying on this loan is going to be $1,232.42 times 12, because 12 months in a year, times 35, because it's 35-year loan. So that's going to be whoa, this is how much you're actually paying for this house, if that's what you're financing. $517,616.40. I think I said that right. All right, so that's how much you're actually paying for the house. All right, so if we're finding the total interest, you just take the amount that you financed and subtract that from the total amount that you paid on the loan. All right, so the total amount paid was the $517,616.40 minus $150,000. So you're paying a whopping $367,616.40 in interest for this house. So this is probably not a smart investment. Seems like you're paying way too much in interest. Now, everything that I'm covering from here on out is not on the test, and it's also not on the homework. But, so if you want to stop now, you're not going to miss anything important. But I wanted to talk about this because I think that it is something that you could use in your real life. All right, so this is going to be about prepaying a loan. So this is going to be where, let's say that you buy a house and you decide, after you've paid on it for 5 years, let's say you decide that you don't want the house anymore and you want to sell it. What I'm about to show you is how you could figure out how much you still owe the bank after 5 years, or however long you've been paying on this loan. Alright, so it says, sometimes a borrower needs to pay his or her loan off early before the loan's term is over. This is called prepaying a loan. When you prepay a loan, you pay off the unpaid balance. And you can find out what that unpaid balance is if you go to the bank, and you can look at it. They have an amortization schedule there, and they can tell you quickly how much you owe. But let's say that you don't want to go up there, you don't want to deal with those people, you just want to figure it out by yourself. If they don't have an amortization schedule already prepared, or like I said, if you just try to do it yourself, you can approximate the unpaid balance by subtracting the current value of the annuity from the current value of the loan. This approximation is usually off by at most a few pennies. All right, so this is going to give you an approximation of how much you need to pay to prepay the loan. This is the formula. I know it looks terrible. All right, so I've written this formula here. So the unpaid balance is P times 1 plus R over 12 raised to the 12t minus the payment times, in the numerator we have 1 plus R over 12 raised to the 12t minus 1 all over R over 12. Now I'm going to add something in here just for calculator purposes. You need an extra, that doesn't even look like a parentheses. Let me try that again. Alright, you're going to need an extra set of parentheses when you're plugging this in. Right here, right here. So parentheses around the top, and then also parentheses around the bottom here. Alright, so go ahead and add that into your formula. Now, very important to note here, P and R are exactly the same as they were in the last formula. P is the principal, R is the interest rate. T is different. T is the number of years that you've been paying on the loan. All right, so not the term of the loan, but how many years you've been paying on it. All right, so here's our example. 10 years ago, Tom and Betty bought a house for $140,000. They paid the sellers a 20% down payment, and they obtained a simple interest amortized loan for $112,000 from their bank at 10.75% interest for 30 years. Their monthly payment is $1,045.50. Their old home was fine when it was just the two of them, but with their new baby, they need more room. I swear I'm not making all these baby problems just because I'm pregnant. These really came out of the textbook. They are considering selling their existing home and buying a new home. This would involve paying off their home loan. They would then use the income from the house's sale to do this. So find the cost of paying off the existing loan. Alright, so they've got a house. They financed it for $112,000 at 10.5% interest for 30 years. Or excuse me, 10.75% interest for 30 years. Alright, they've been paying on the loan for 10 years. Alright, I know that because of right here. Alright, so they've been paying on the loan for 10 years. And it tells us their monthly payment is $1,045.50. Alright, so we're going to calculate how much they're going to have to pay to prepay the loan, so the unpaid balance. Alright, principal. The principal is the amount that they financed. That's the $112,000. They throw these extra numbers in there like $140,000 and 20% down payment. They put those extra numbers in there just to try to confuse you. Alright, so we know the principal. Interest rate, 10.75%, so that's 0.1075 in decimal form. And then the term, or the time that they've been paying on the loan, well, sorry, I'm actually doing the payment first. The payment is $1,045.50. And then lastly, T, the time or the number of years that they've been paying on the loan, is 10. Whew, so let's plug this in. Alright, so take a second, look this over, or copy it down if that's what you're doing. Alright, so we have 112,000 times 1 plus 0.1075 over 12 raised to the 12 times 10. You know we're going to have to take care of that first. Minus $1,045.50 times 1 plus 0.1075 over 12 raised to, again, 12 times 10. Minus 1 over 0.1075 over 12. Just like last time, don't forget about putting the extra set of parentheses around the top here. And this is just for calculator purposes. That's the only reason I'm adding these in here. Just for when you're plugging this in the calculator. Just like I said, you got to take care of these first. Alright, so if you don't take care of them first, it requires you to do an extra step in the calculator, and it's just easier just to multiply these out first. Alright, so 12 times 10 is 120. Now I'm going to have to adjust my little parentheses here. Alright, I took care of that. Now we're just going to plug this in our calculator. Okay, so I've put this on its own little slide so that we could have more room. Let me add in the parentheses real quick. Alright, so you see in the top, notice that there's going to be a double, actually we're going to end up with a triple set of parentheses in one spot. So now I'm going to show you how I plug that in the calculator. Again, I'm going to let it run through one time and then I'll explain what I did. Alright, so let's go through that. So we have 112,000 times 1 plus 0.1075 over 12 raised to the 120 minus 1,045.50. Now big parentheses, second set of parentheses, and then a third set, and then we're starting up here in the numerator, 1 plus 0.1075 over 12 raised to the 120 minus 1 close parentheses divided by open parentheses again 0.1075 over 12 close parentheses, and then close them one more time. That last one takes care of the very outside parentheses here. Alright, so there is the amount that they still owe on the loan. This is how much they would have to pay to prepay the loan. So $102,900, let me start that over, $102,981.42. Alright, so once again, since they are still fairly early on in their payment schedule, since the loan's for 30 years, they've only been paying on it for 10 years, they're not even halfway done. They still owe most of the principal because so far they've mostly just been paying interest. Alright, so like I said, what we just did here, this unpaid balance stuff is not on the test, it's not on the homework. I just wanted to show you how to do this because I think it's useful and I think it's interesting. Alright, but if you have any questions about amortized loans or about if you're doing something wrong in the calculator, make sure to send me an email. You can send me a picture or a screenshot of your calculator, and that'll really help me to figure out where, if anywhere, if you are making a mistake. Sometimes the calculator is just a little bit off, and then I can just go in and give you credit for it on the homework. So don't get discouraged, just send me an email and I can help you out. Alright, see you guys in the next video.